Now that you're interested in that, you should go follow David Eng in YouTube. He's really smart and really funny.
Let's go over the Chapter 5.1 Normal Distribution Test. How do you know the difference of the versions? This I'm going to call the lowercase because here is a lowercase. Alright, first question we see is question number 6. Which graph is the best representation of a normal distribution? Well, what is a normal distribution? There's a couple of things. Number one, it's symmetrical. Means you can cut it in half or fold it in half and it's exactly the same. I'll just write equal halves. You know, think of a heart. Symmetrical. Number two, it's called a normal curve. Or we've been talking about the paranormal, right? Like that ghost. Looks more like a blob. And the third thing is that there's only one peak. Okay, 6A, this one has one peak, but this one you can't cut in half, right? It looks like a lot of the data is pushed to one side there. So not that one. B, this one has two peaks, 1, 2. So if you just had one of those, that would be fine, but you have two of them, so that one has two peaks. No. This one they call bimodal. Bi meaning two. So if you have one peak, unimodal. Oh, that's really bad handwriting, guys. Sorry. Okay, so C is symmetrical if you cut it in half, but you kind of need it's not a normal curve. So our question number 6, the answer here is D. All right, here's question number 2. Based on the following grouped frequency table, or for us, we're saying that this represents a frequency table of income, or how much money you make, which is the variable X, of 30 employees at a local business and measured in thousands. So again, this will you just multiply those, so you get 26 times 1,000, you would get, this was a category of someone making $26,000 annually. And this would represent $28,000. Okay, the relative cumulative frequency of 28 is less than X less than or equal to 30 class is, so right now we have a frequency and we need to make a relative frequency. And basically what you would do is you would take the total, which we already know is 30. You can do 2 plus 11 plus 8 plus 5 plus 4, and you will get 30. So if you divide each of those by 30, you'll get 2 out of 30 to be 0.067. Alright, so with 0.067, which one is closest? It's either going to be C or E. Well, it's not 70%, so that would be wrong. Your correct answer would be C. Now, a couple of things that you'll see on yours. This one we said was supposed to be D, you guys had the choice of 2. Now this one is just a frequency, a count. And this one is talking about a relative frequency. And that's which one we wanted. All right, question number 14. The graph of which normal curve is most spread out? Spread out is a measure of center. Measure of spread. And spread is actually the standard deviation. Mean, median, and mode are measures of center, which is here in blue, and we don't need that. So measure of spread, I'm trying to just basically look for the one that has the largest number. And there's the largest number. So 14, your answer is D. The normal curve, which has the most spread out, is the one that has the greatest standard deviation because it's a measure of spread. Question number 3. Approximately what percent of data in a normal distribution, so let's get ourselves a picture here, normal distribution, I'm going to draw my paranormal ghost curve. So what percent is between the mean, so here is the mean that I have here in blue, and two standard deviations below. 2 standard deviations below the mean. Okay, so I have 1, 2. This we call 2 standard deviations below. Okay, so you need to think about in this one the empirical rule. Empirical rule. Okay, so that is 68%, 95%, and 99.7%. And that's 1 standard deviation, 2 standard deviations, and 3 standard deviations away. So this one says 2 standard deviations away, which means this. So you go to the 2's, okay? And everything in yellow, from here to here, all that shaded region here represents 95%. Now pay attention. This problem is only asking for from the mean, which is the blue line, to 2 standard deviations below, which is towards the left, so here. So they basically want to know how much is just half of that to the left. Well, if you take 95 and divide it by 2, you'll get 47.5%. So this is 47.5%, and that would be choice C is your answer. All right, question number 8. The heights of a large group of women are normally distributed. So that just tells me draw a normal curve with a mean of 65 inches. So that again is a measure of center. And a standard deviation of 2 inches. So every time you go out 1 from the center, this is 1 standard deviation, or in this case we would add 2 inches. Add 2, and this way you would just subtract 2, subtract 2, subtract 2. And so it's 2 standard deviations. Let me kind of show you. It's count 1, 2. Does that make sense? And then this out here would be 3 standard deviations. And then going towards the left, it's 1, 2, that tick mark is 3 standard deviations. So let's get some numbers to that. So if you add 2 to 65, it would be 67. If you add another 2, you would get 69, 71. And then just subtract 2. So 63, 61, and 59. So you can just see that you're counting by 2's there in the green. Okay, so they want us to calculate from what is the probability. Remember, probability, whoops, is just another word for percent under the curve. And we're starting at 61, so here's 61 to 67. Okay, you could do two things. I'm going to show you by hand, and then I'll show you by technology. Okay, so basically we want the area between the blue and the black. Okay, so if you do the blue, the light blue, let's go get that light blue, and you do it from 2 standard deviations away. How do I know that? That's the 2 right here. Center, 1, 2 standard deviations. Remember, this blue area here, that represents 95% from the empirical rule, right? Watch me do some magic. Thumb. This is what I'm referring to. So, let's see. Okay, so I am using 2 here, so that's a 95% for the whole region. And you cut that in half and you get 47.5, 47.5, okay? All right, if we do the black, this one is only 1 standard deviation away. So there's the mean. And this region here in black represents 68%. So that means half of that is going to be 34%. 34%. Okay. So let's divide this up. What do I got? 34. This represents 34. But this light blue region has to equal 47.5. So I'm going to call this one X. So essentially you have X 34, and the whole thing was in blue 47.5. So X plus 34 equals 47.5, and you subtract 34, you'll get X to be 13.5%. So just that yellow region is going to equal 13.5%. Whoops, come on. So basically, if you add up 13.5 plus 34 plus 34, you're going to have 68, and you'll get pretty much close to 81.5, which is 0.819%. Okay, so that was by hand. A lot of work. You can do it by the empirical rule. And the next one I'm going to use technology, and I'm just going to use the TI-83 even though I showed you guys the Desmos. We're going to use our norm, CDF, and I forget, so you're going to use plums, which means your probability is equal to your lower, upper, mean, and then your standard deviation. So your lower would be the number 61. your upper would be 67. Your mean is the center, which is 65, and your standard deviation, which is 2. Let's put it in. So that would be second vars, which is next to the down key. Norm CDF is number 2. So we said that we were going to use forgot my numbers. 61, 67, 65, 2. Close the parentheses, enter, and you get right there 0.819, or you round up 81.9. So that one's done by technology. All right, this problem kind of goes through why some teachers and at colleges, professors say they grade on a curve. A professor grades on a curve. Scores within 1 standard deviation are C's. All right, so I'm going to go ahead and draw a normal curve. And there's the center, and this is within 1 standard deviation, right? And so this yellow region, that represents a C. Scores greater than, sorry, I was going to say that I colored this part here in yellow. Scores greater than 1 standard deviation above the mean scores greater than 1 standard deviation above the mean and less than 2 standard deviations above the mean are B's. So scores that are 1 standard deviation above the mean. So from here, this green point, and less than 2, so starting from here to this side, this is what they're talking about. This green region here represents B's. And less than 2 standard deviations, because this would be a second standard deviation. Okay, so let's go to this last one. Scores that are greater than 2 standard deviations, so starting at 2, greater means going towards the right, so going towards that direction, tells us are above the mean are A's. So here, that red region represents an A. On an anthropology test, the mean score is 68, so there's the measure center right in the middle, and the standard deviation is 7. So remember, you just keep adding 7. What score will earn an A? Okay, so let's figure out the numbers here. 68 plus 7 gives me 75, and then 82. Okay, so what scores will give you an A? So I need something that is 82 or more. So no, no, yes, and yes. So in this problem, actually, there are 2 choices. Now, because of the Google Forms, it says select all that apply. I said if you either pick C or D, you will get the correct answer. All right, number 7, Lily often orders takeout from her favorite Chinese restaurant. The restaurant's mean time for preparation is 20. So mean equals 20 minutes. And the standard deviation is 8. The preparation times begins when customer places an order. Which is the probability that Lily's order will be ready in 25 minutes or less? So let's go ahead and get ourselves a curve here. Green is the mean, 20. Okay, so then we want 25 minutes or less. So this is going towards the left. So 25 is a number that's greater than 20, so I'm going to put it up here. And basically, we want to find this area in red, which is going to be a percent. So we can do it by formula. Let's do this by formula, and then I'll show you the technology. I'm going to first find, okay, so this was the picture, and then formula. So z equals x minus mean over the standard deviation. I'm going to find the z-score. So the x value is 25, and our mean is 20, and our standard deviation here in blue is 8. So this will give me 5 over 8. And if I turn 5 over 8 into a decimal, I get 0.625. Okay, so now I'm going to look for a z-score of 0.625. And when I'm doing a z-score, that's on the outsides of my table. You'll notice that over here on the left side is negative numbers, so I'm going to go to a positive. Let me get a color that we have not used. It's all kind of messy and written up. Okay, I got 0.6. And then I got, if you think about this, this is 0.20, 0.030, so this is 0.025. Okay, so in between those two. So I'm going to take the average of these two numbers, which means I'm just going to add them together and divide by 2. I'm going to say it out loud. It's kind of hard to show you where my phone is. There it is. Let me go grab it really quick. It's right there. Beach. Oh man. All right. All right, let's just show you guys. So 0.73237 plus 0.73565, and then divide the answer by 2, and I get 73,401. Okay, so that's my z-score. I'm sorry, not my z-score. My z-score is 0.6 plus 0.025 gives you that number that we needed, which is, I'll write it here in blue. I can't. It's too small. Let's go back. Okay, so z to a percent gives me 0.73401. Okay, so basically the z-score helps us find an area under the curve, which here in red, and that's that whole red region, 73%, which is which choice? That would be D. Okay, to do that for the calculator commands, this is using a TI A3 equivalent, and you're going to find a area under the curve, so you're finding a percent. I use plums, which means a percent is equal to normal CDF, which means continuous density function. L is the lower limit, so over here you're going to have like negative 9,999. We say that because it's basically negative infinity. And then my upper limit is 25, the mean of 20, and standard deviation of 8. Let's put that in. Again, second in top left, then vars underneath the bottom arrow, down arrow. Number 2, Nice thing is this kind of tells us, so we're just going to type in the numbers, negative 9,999. Remember that in this calculator, the negative and subtraction are different, so do not press the key in blue, and mine would be to the left of enter. Comma, no spaces, 25, comma, 20, comma, 8. And look at that. That was the same number we got from the chart. So that is our answer. All right, question number 9. The weights of a group of 10-year-old boys are normally distributed, with a mean of 70. Here it is. And a standard deviation of 12. What is the z-score? So z is equal to what for a 10-year-old boy who weighs 64 pounds? Okay, this is the hard one in the sense that the 64 pounds is your x. X equals 64. So let's give you a visual. Let's draw a picture. 64, to the left or to the right? Somewhere right here, right? All right, basically what we're trying to do is we want to find a z-score for this. Well, if you just use the formula, let's just plug in everything we have. Z equals x minus the mean over the standard deviation. Okay, so our x was 64. Our mean was 70. And our standard deviation was 12. So, you get negative 6 over 12, which is negative 6 times, no, let's do it the other way. Negative 1 times 6, 2 times 6. 6 is canceled, so you're basically left with negative 1/2, which is negative 0.5. And that would be what choice? That would be choice B. And that should make sense because the orange 64, the weight of that boy, is to the left of the mean. Remember, left is a what? Negative number. Let's make that obvious. Let me say that again. Negative number basically means a z-score of negative are this way. And you see that in the 64. All right, number 19. Normal curves A, B, and C represent the battery lives of cell phones for 3 different companies. Which statement is true? Select all that apply. I only let you guys pick one answer, and there's could be multiple answers. All right, I'm going to color code these. So A is my yellow one here, and B will be my blue one, and green will be C. Okay, so it says each company's cell phones have the same mean battery life. Okay, so the mean is a measure of center for that color. So for example, this is that number. Let's just, I don't know, it's super helpful to just put some numbers to this if that helps you. I don't know, you could just start out like 5. Each tick mark is 5, so 5, 10, 15, 20. You don't have to do everything. It's just to give you an idea, right? So let's just say the mean for the yellow is 20. And let's say the blue something like that. We're just close. We're saying it's 40. In green, the center would be 60. So are those all the same number? The answer would be what? No. That would not be true. Okay, B. Each company's cell phones have the same standard deviation from the mean battery life. All right. I'm going to pick a different color here. So standard deviation is a measure of spread, like you're spreading the jam. And if you think about it, the distance between here and here, that's like a distance, we did it, of 30. And then if you actually move this, let's do that. If I can do that. Can I do that? No. What happened to it? You see, if I move it, it has the same distance. 25 to 55 is a distance of 30. And then this one also has a distance of 30. So the spread doesn't change. You see that? The jam and how far you spread it out from the center is pretty much the same exact thing. I'm going to erase that. So it does have the same, so that is true. Okay, let's look at C. The battery life of company B's cell phone is between the mean battery life of A and C's. Okay, so we're saying that B is in between, so A and C. So can you put the means just like that? Well, it is. We have 20 and B is blue, so 40 and then 60. So that is true. And then the last one, company C's cell phones have a greater standard deviation from the mean battery life than A's or B's. Remember, I just showed you that orange line. Should I show it to you again? This orange line is the same distance as B's and A's. They're all the same. So the green one, C, is not greater. So that one would be wrong. So our two answers are going to be B and C for number 19. Scores on a standardized mathematics test are normally distributed. So let me go ahead and draw that curve. Here's the ghost. Okay, then it tells us with a mean of 500. So right down the middle is 500. And a standard deviation of 120. So you'll just add 120 and then subtract 120 in that direction, okay? All right, which of the situations has a probability of 0.025 of occurring for a randomly selected test score? Okay, so they want to know what 2.5, remember this, if you move the decimal or multiply by one, or multiply this number by 100, you're going to get 2.5% parts out of 100. So let's go ahead and just mark up our picture here. This might help you. Okay, so this would be 620, 740, and 860. We subtract, you're going to get 380. Do it again, and you're going to get 260, and subtract 120 again. You will get 140. Another way of thinking of this is 3 standard deviations away, right? Standard deviation is 120, so that would be negative 360. So if I just subtract here, you get the 140. Does that make sense? Okay. All right, which one will give us a probability of basically 2.5%? And when I think about that 2.5%, watch, I'll show you guys here in red. It's these two tails. How do I know that? Well, again, that's the empirical rule. 68%, 95, 99.7. And again, that's 1 standard deviation, 2 standard deviations, and 3 standard deviations. If you look at... Oh, I made a mistake. Can you count my mistake? That 2.5% is this one. And so I should have been at 2 standard deviations. The red line should be right there. Right there. You see the mistake? So it's just all this red region. Remember, if you need to write yours, 1, 2, 3 standard deviations, 1, 2, 3 standard deviations. Okay, so basically, that's my picture. And so really what I want is that this red regions, again, represent 2.5%, and this is 2.5%, and in the middle, this will be the 95%. Let's use yellow. So yellow represents 95%. So 2.5, 95, and 2.5 equal 100%, and then the two tails, the 2.5 plus 2.5, that's really 5%, right? So 95 plus 5. Okay, so for one of those choices, I want scores that are less than 260. And I see that in B. Scores less than 260. That represents the red region. And if I go over here, the red region starts at 740 and more. So this would be greater than. If you're going towards the right, and to the left, it's less than. So more than 740 would be D. 16 would be both B and D. Again, if you pick, I only am allowing you to pick one choice, and if you get B or D, you're correct. Question number 20. A data set has a mean value of 4. Let's color code this for you. A mean value of 4. And I need to change that. There's a typo. And a standard deviation of 0.2. So plus 0.2, plus 0.2, and plus 0.2. And you can subtract 0.2, subtract 0.2, and subtract 0.2 to get to that third one. So those scores would be 4.2, 4.4, 4.6, 3.8, 3.6 to 3.4. And to make this super obvious, okay, so this would give you basically a z-score of, or a standard deviation of 0. And this would be a standard deviation, 1 standard deviation, 2 standard deviations, 3 standard deviations, and going left there, negative. Okay? Which z-score represents sorry, I'm missing some stuff on here. Which z-score does not represent a value within 2 standard deviations of the mean? Okay, so 2 standard deviations of the mean would give us right here. Why? Because that 2 represents that 2. So they want to basically know, sorry, I'm incorrect on here. They want to know a z-score. Well, it is 0, 0, but I wanted to bring it down. Let's do that in a different color. Okay, so which z-score does not represent a... So you can use the formula. Watch. Let's use the formula. Let's kind of color code this for A. I'm not saying A is the answer, but I'm showing you. Z equals x minus the mean over the standard deviation. The data point that we're trying to solve for is x. So the z is negative 1.5, x minus the mean value, which is 4 over 0.2. And remember, you just cross multiply. And then just add 4. So for that choice, if you have it, that would give us plus 4 would give me 3.7. So .7 would be right here. And this is within. And think about that. A z-score is negative 1.5. Does that make sense? And I'm trying to show you that it's in the red region, but we're trying to find one that's not in the red region. Let's try a different one, negative 0.3. So I'm showing you both formula and algebraically and using the picture. So negative 0.3 equals, we're trying to solve for x again, 4 over 0.2, cross multiply, x minus 4 equals negative 0.3 times 0.2, and of course you'll be adding 4, so then if you put that into your calculator, negative times 0.2, and then plus 4 gives me 3.94. Again, this should make sense because a z-score of negative 0.3 is at 3.94, which is like right here. So 3.94 has a z-score of negative 0.3. It's negative, so that's also in the red region. But I'm not looking for ones in the red region. One's looking for the outside. What do you think the next one's going to be? 1.8. So a z-score of 1.8, 4 over 0.2, you'll get x over 1, and then cross multiply x minus 4, 1.8 times 0.2. Going faster because you already know how to, hopefully I've shown you how to do that. So PEMDAS 1.8, multiply, then add. This gives me 4.36. Again, this should make sense. 4.36 is like right here, right? And it has a z-score of 1.8. Can you see that? Okay, where is 3.8? And that, again, the other one is in the red region. But I went outside the red region. Look at 3.8. Where is 3.8? 3.8 is going to be somewhere over here. Does this make sense? Outside the red region. Let me prove that to you. There's a formula, our z-score of 3.8. Trying to solve for x. Mean is 4, standard deviation 0.2. So I have 3.8 times 0.2 plus 4, it gives me 4.76. And 4.76 is like way over here, and that's outside the red region. So our correct answer for number 2 is D. D is a z-score that does not represent a data value within 2 standard deviations. See you guys.
Now that you're interested in math, you should go follow David Eng in YouTube. He's really smart and really funny.